In this section, we're going to be looking at how was the periodic table developed, what are the elements and the features of the periodic table, what's atomic number, what's atomic mass, and why do we need periodic table. To answer the question why we need periodic table, if you go to a grocery shop and you want to buy some fruits and you see that all the apples, pears, and the mangoes, pineapple, everything is kept in one basket, would it be a easy experience shopping? So similarly, the elements need to be organized in the periodic table in order to better understand the periodic table elements. And how was periodic table developed? The development of the periodic table, it was developed in 1743 by a French scientist, Antony Levensier. So he basically found few elements and he started organizing all of the periodic table. Totally 33 elements were known at that time. Slowly, with the advent of electricity, people started uh, applying the heat energy, and compounds would be broken down into individual elements from the compound state and isolated the elements, and that resulted in we had around 60 elements in the 1860s. And there were several other scientists who put in their hard work, and finally the periodic table is what it is today. It was classified basing, based on gases, metal, non-metal, and earths contribution to the classification of elements. John Newlands from 1837 to 1898, he contributed towards arranging the elements by increasing atomic mass. He noticed a repetitive property every eighth element, hence he created the law of octaves. Oct meaning eight. Next we have Lothar Meyer, who was from 1830 to 1895. He demonstrated a connection between atomic mass and the elemental properties. Therefore, he arranged the elements in increasing order of their atomic mass. Then we had Dimitri. He demonstrated a connection between atomic mass and the elemental properties and arranged the elements in increasing order of atomic mass. He predicted the existence and properties of undiscovered elements. Then we had Henry. He was also a scientist and he discovered atoms containing unique number of protons called atomic number. Hence, the periodic table now has the elements arranged in increasing order of atomic numbers, and that gave the pattern of periodic table of properties. The periodic law, understanding what periodic law is, the statement that there is a periodic repetition of chemical and physical properties of elements when they are arranged by increasing order of atomic number. It's called periodic law. We have the modern periodic table now, where elements are arranged by their atomic number on the top. For example, oxygen, whose element symbol is O, and periodic table atomic number is 8, and the atomic mass is 15.999 approximated to 16. So now all the elements are grouped based on their groups and periods. Hydrogen is in period 1. There are lots of total 7 periods. Each group is from number 1 through 18. For example, period 4 contains potassium, calcium, sodium, scandium, is in the third column from the left, which is in group 3. Oxygen is in group 16. The elements in the group 1 to 13 to 18 possess a wide range of chemical and physical properties. For the reason they have been referred to as main group or representative elements. The elements in group 3 to 12 are referred to as transition elements. Elements are classified as metals, nonmetals, and metalloids. Metals. Elements that are generally shiny, smooth surface, clean, solid, and at room temperature, and they are good conductors of heat and electricity, are called metals. Most metals are malleable and ductile, meaning that they can be pounded into thin sheets and drawn into wires, respectively. You can look at the boron. For example, you have a heavy stair step line, and the stair step line is visual divider between the metals and the non-metals in the periodic table. Then we have the alkaline metals, which is except for hydrogen, all other elements in the left side of the periodic table of elements, which is group 1 of the elements. They are called alkaline metals because they are reactive alkaline metals, and they usually exist as compounds with other elements. Two familiar alkaline metals are sodium and the components of salt and lithium, often used in batteries. Alkaline earth metals. The alkaline earth metals are in the group 2 and they are highly reactive. Calcium, symbol Ca, magnesium Mg. Two minerals important for your health are the examples of alkaline earth metals because magnesium is solid and relatively light. It is used in the fabrication of electronic devices such as laptops. Thanks for watching. Please stay tuned and do like, share, and subscribe to my channel.